So, get this. One of the most mind-bending ideas about the limits of science, it doesn't come from a modern lab. Nope. It was actually proven using simple geometry nearly 600 years ago. Today, we're diving into what's known as the polygon theory.
I mean, that sounds completely wild, right? We're talking almost 600 years ago, way before what we'd even call the scientific age. And a cardinal, of all people, supposedly used math to prove that we can get infinitely close to the truth, but we can never, ever actually get there.
So yeah, how is that even possible? That's the big question we're going to unpack here. And the crazy part is, the answer isn't buried in some modern physics textbook. It's hidden away in the writings of a 15th century cardinal who, it turns out, was also a heck of a mathematician.
All right, let's get into it. Our story kicks off not in a laboratory, but deep in the world of philosophy and theology, with a guy who saw the universe in a totally different way.
Meet Nicolaus of Cusa, also known as Cusanus. This guy was fascinating. He lived in two worlds. On one hand, a powerful cardinal in the church. On the other, a total polymath who was obsessed with math and astronomy. And he was wrestling with this massive problem. How can our little, finite human minds ever hope to understand an infinite, perfect reality? It's a huge question.
So in 1440, he drops his masterpiece, On Learned Ignorance. And that title? It says everything. For Cusa, real wisdom wasn't about cramming your head full of facts. No, it was about becoming an expert, becoming learned in your own ignorance. It's about knowing the precise limits of what you can't know, and to get this idea across, he came up with this brilliant, super simple analogy.
So how do you explain a philosophical idea that big? Well, he didn't use complicated theology. He used a simple, elegant geometric picture that is, literally, the key to his entire argument.
Okay, here it is. Just look at this. You've got a polygon drawn perfectly inside a circle. See how all of its corners just touch the edge? Cusa said that this simple picture, this relationship right here, holds the key to understanding everything about human knowledge.
So here's the breakdown, and this is the crucial part. Cusa wants you to think of the circle as absolute truth. It's perfect. It's whole. You can't break it down. Then you have the polygon. That represents our human knowledge. It's built out of straight lines and sharp angles. We construct it, one piece at a time. And here it is in Cusa's own words. He says, "Our intellect has the same relationship to the truth as a polygon has to a circle." So let's run with that. What happens when we try to make our polygon look more and more like the circle?
Okay, think about it like this. Every side of that polygon is a piece of human knowledge. It's a scientific fact, a new discovery, whatever. We can keep adding sides, right? We can go from a triangle to a square, to a shape with 1,000,000 sides, 1,000,000,000 sides. And yeah, it's going to look almost exactly like the circle. You'd barely be able to tell the difference. But, and this is the kicker, it can never actually become the circle. Mathematically, there will always be this tiny, infinitely small gap between the straight line of our knowledge and the perfect curve of truth.
So, what's the takeaway from this geometric proof? I mean, this isn't just a fun math puzzle, right? It's a really powerful philosophical statement. And it's not about being pessimistic and giving up on knowledge. Not at all. It's about completely changing the definition of what it means to be wise.
And this is what he called learned ignorance. It's this deep understanding that our knowledge, all of it, is basically just a really good guess. Why? Because we can only measure finite things using other finite things. We can't make that final jump to perfectly measure something that's infinite and whole, like absolute truth.
And that leads to this pretty radical conclusion when you think about it. Every single theory, every fact, every bit of knowledge we have, it's all, in Cusa's view, a conjecture. Now, it might be an amazing conjecture, like a polygon with 1,000,000,000 sides, but it's still just an approximation. It's not the real thing.
Now, you might think Cusa's idea sounds totally revolutionary for the 15th century. And it was. But he was also tapping into a way older tradition of thinking. In fact, we can see a similar approach to truth bubbling up more than 1,000 years before he was even born. You can actually trace this idea, this intellectual thread, from the ancient world right through the Renaissance with Cusa and all the way up to how scholars deal with complex texts today. Okay, let's jump back to the 3rd century. There was this scholar named Origen, and he had a massive problem. There were all these different versions of the Old Testament floating around, and he had to figure out which one is the true one. His solution was, frankly, genius. Instead of choosing one, he created something called the hexapla. He just laid out 6 different versions in parallel columns: the original Hebrew,
Hebrew written in Greek letters, and 4 totally different Greek translations.
And here's the amazing part. For Origen and the people reading this, the truth wasn't in any one of those columns. It was in the space between them. It was in the comparison, the differences, the dialogue you could have by looking at all of them at once. You see the connection? Each column was like a side of Cusa's polygon, and the real meaning was the circle that they were all trying to describe.
Which brings us all the way back to the present day. Because this exact same idea, getting at the truth by looking at it from a bunch of different rigorous angles, is still, at its core, how we search for knowledge.
Just take a look at how modern scholars try to figure out an ancient text. They don't all use the same method. They have these different super specialized toolkits. So one group might be all about its theological meaning. Another group might only care about a strict historical analysis. And a third group might just focus obsessively on the grammar of the original Greek.
Here's the thing. None of these methods are wrong. Not at all. Each one is a super sophisticated, disciplined approach. They're all just different polygons. Each one helps us get closer to the truth of the text from its own unique angle. But not a single one can say it has the complete picture. The search just keeps going.
And maybe that's the real beauty of Cusanus' theory. Realizing that our knowledge is always an approximation, that's not a failure. It's actually what makes the whole quest for knowledge so exciting and so important. It's what keeps us humble, it keeps us curious, and it keeps us always striving to add just one more side to that polygon.
So, I'll leave you with this question to chew on. If we can never, ever reach that perfect, absolute truth, if we're always just making our polygon a little bit better, then what's the real point of the chase? What's the true value of learning and discovery if the finish line is always out of reach?